Okay guys, this video is going to explain the difference between what I call a construction. If we do this by paper and pencil, we use compasses. Circle properties help us understand congruence with their radii, and a straight edge, and really in a protractor. So those are the main tools that we do by hand. Those tools can be represented with GeoGebra. So constructions on GeoGebra and constructions on paper, logically, mathematically speaking, are really the same thing. It's just that physically in doing them, using the computer program and actually using a compass, for example, are different. We have points and we have to do certain things in GeoGebra. So I want to go over that difference. You will be doing constructions by both computer and by hand throughout the year so that you can appreciate both and just know how to use your hands as well. Okay, so here's what I'm going to do. Let's put a title on this. So as we watch this video, we can keep the title up here. I can also show you how to put your name on stuff and whatnot. And that's with the text tool here, this ABC, so insert text. Okay, grab that tool. Notice right now if you have your graphics options down here, we can make it small, bold it, italicize, we could change the color. Okay, so what I always do is I just click somewhere on the screen. It's going to open up a little text here. So I'm going to call this the difference between constructions and looks like it. I'm going to call it looks like it because a lot of times I see students just make it like, we're going to make a square, for example. And a lot of times they just make something that looks like a square, but I'm going to show you what a construction is versus looks like it and how I know what's what. Okay, so now notice my text here. It's kind of boring. It's small here. So I'm going to go up here. I'm going to maybe make it very large so it stands out. Man, that's pretty large there. Maybe large. Okay, so I'll just keep this up here. Let's get rid of that grid and that axis too. Alright, so let's keep that up there. Maybe bold it. Yeah, it looks pretty good. I'm going to make this blue. Alright, so the difference between constructions and looks alike. So let's over here call this side, I'll grab my text tool again. We'll call this the construction side. Please, for this quest, you're going to have to submit your screenshot of this app that you're following along with me. You're doing the construction, you're understanding the difference, and then you're going to submit your picture. Okay, so this will be our construction side here, and this is what you need to set up to. I want it to look like mine, just because I'm showing you steps and you can follow along with me, I hope. We'll call this the construction side. I'm going to grab my text tool again, and over here we'll call this the looks like it side. Put the dot 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 there. Alright, looks like it. Maybe make it large again, bold it. Maybe I want this one to be green. I like doing different colors. Okay, so over here, well, let's do the looks alike first. Let's make a square. One more text. Make a square. Alright. That way too, and if we label everything nicely, you can use this as a reference. So when you look back at it, and the nice thing about a Windows folder is you can actually look at the pictures of the file. So if this was an actual picture you took like a screenshot, you could look at this later and then you can use it for review. So these are notes as well. You guys got to understand that notes just don't go in a notebook all the time. Maybe very large here. Right? So take care of yourself. Make sure that you're understanding this. Okay? So let's do the looks alike. So we're going to make a square here. Now, square, we could do a couple things. It's got 4 corners on it, right? And each corner we can call a point. Maybe I can grab my point tool and I could do a square. Those look like that would be somewhat like a square, right? You could also, instead of doing that, I'm going to do Control Z, which is undo. Also, this yellow arrow up here is undo. But I'm going to undo that. I'm going to grab my segment tool. A segment's part of a line, so it's going to be in my line toolbox here. So I'm going to grab my segment tool, and I could just go endpoint to endpoint. Start my next segment here. I'm going to click on B, so that B is now the endpoint of another segment. So that this segment and this segment share B, and now I can put, say, this point down. That looks like something like a square. I'm going to click on C, segment, D, finish, right? Close it off here. So now that doesn't quite look like a square, so maybe I'll make it look like a square, right? I hope you understand the look alike here. So you might go, you know what, that's close enough for all I care. But you know, that's not, one, it's not a square. I can measure the sides here. This toolbox here that has the angle picture on it, this is our measurement toolbox, so you can measure angles if you want to. So in a square, each angle in here we should know is 90 degrees in here, right? Or the sides are perpendicular to each other, right? Because they're at a 90-degree angle. So I'm going to grab my angle tool and I'm going to measure this. And as you hover over it, notice it says select 3 points or 2 lines. When you select points to measure the angle, like I want to measure this angle in here, you have to select your points in a clockwise direction. So when I click, click, click the 3 points of my angle here, they need my direction has to go in a clockwise direction, right? D to A. You always do your vertex point second when you do an angle. Notice now GeoGebra is waiting for me to finish off my angle, which is B. So when I do B, 88.63, that's not 90 degrees. It looks like it could be, but it's not. It's off. Even though it's off a couple degrees, it's off. So it's not a square. Now also we know that in a square, the sides have to be equal, right, in length. So back in my measurement toolbox, if you hit the down arrow, you can do your distance or length tool. So if you click on that, I'm going to just click on this segment here and it'll tell me the length. It's 4.7 units, whatever that happens to be. So if this is a square, all the sides better be the same length, right? Now you might say, alright, well if I know that measurement and I know that that's 90 degrees, maybe you measure them all, I could make this look like, or get all these segments by moving everything around. I bet you could make a square, but you should time yourself because that's pretty hard. Now let's go over here on the construction side. Let's construct a square and using relationships we know. And one way I'm going to show you, just to show you some tools and get used to this, is let's grab a circle. We need to talk some circle logic here. Okay? When we do a circle, and you have your circle tool here, and I click on to a center point, the distance between that center point and the point that I'm going to make as soon as I click, that distance is the radius of the circle. The radius is not just the segment. The radius is also the distance between the center and every point on the circle, right? So once I click, for example, that's a radius, that's a length. There's a distance between E and F, right? That's the radius length. If I want to see it, this is why in geometry we always see segments and things. It's the visual distance, right? That segment. And segments are nice too because we can see them as sides. We can see relationships. So for example, we know that, oh, okay, let me finish my thought and then I'm going to do another thought with point color here, another pointer for GeoGebra. Okay, when you, like for example, I'm going to make another radius. I'm going to grab my segment tool here. So I want another radius that's going to be endpoint at the center. That's the definition of what a radius is. A segment whose endpoint is at the center and on the circle. So now when I click on the circle, this is my point here. Notice and that color of the point is like this purple color, right? Now notice these 4 points, A, B, C, D, and my center point are this deep blue. And you can also see the colors in your algebra window. All these points here are blue. These are not blue, right? Okay, and I'll show you the difference. Blue points, whenever you click on a point on your screen, blue points are free moving objects. That means that you can click on them and you can move them around, right? I can just move E, which is moving that, changing that distance between E and F, for example. So it's changing my radius, but still I can move that point around. F was that other point on my circle, which I can move around and change the radius that way as well, right? Notice these points over here, we could click and drag them and move them around. So blue points mean you can move them around. They're not tied to anything. Now that purplish color point means that you can move the point around, but it's confined to an object. So when you click on the circle and put a point there, it's going to by default be this purple, and you know by looking at it it's going to be stuck to the circle here. So pay attention to color. The other thing with color here, I'm going to just grab my line tool to show you intersection points. Fixed points have a different color as well. So I'm going to click, say, maybe this point here on the circle. Notice it's that purple. And this point right here, oops, I don't want that point. Sorry. This point here and maybe this point here, right? So they're purple, they're on the circle. I can move them around. Okay? Now notice, maybe I want this intersection point. I want to highlight it. So what I can do is grab my new point tool and I can just hover over that intersection and I can just click on it. Notice both segments are highlighted, so I know I'm on the intersection. So now I'm going to click on it. Okay, now K comes up and it's a different color. It's like a darker, like dark gray color. That means it's fixed. So if you grab your move tool, you can't change anything. Okay, so that's pay attention to point color. All right. So anyways, back to the circle here. I'm going to go back to my radius here. Now, one way that we can make a square is if I extend, I'm going to grab my line tool. Okay, I'm going to extend this segment here because I want it to go to the other side here, make a diameter basically, right? I want this point here. Now, if I'm making a square, if I had a segment that was, say, perpendicular to this, right, 90-degree angle here, I bet we can make a square. So this is called our construction toolbox, and it's a construction toolbox because we can actually make every one of these tools by hand. All right, so notice all the tools that we have here. I want a perpendicular line, so I'm going to click my perpendicular line tool. To use this, if you hover over it, select point and perpendicular line. Well, that doesn't make much sense. Here's how you use this. Since I want to be perpendicular to this line here, this is the logic you can tell yourself when you use tools. If I click on the line, I'm telling GeoGebra I want to be perpendicular to this line. And notice it makes a perpendicular line, and it's just waiting for me to click somewhere where it'll make this line go through a point. Now I want it to go right through the center of my circle. So I'm going to click on the center E, and now I bet you, if I grab my segment tool and click on these intersections here, those would be like the vertices of my square, right? Those are the corner points. So as I go around the circle here, using geometry, we don't really know exactly why, but you can see kind of congruence in here, can't we? Congruence alone, by the way, is how we're going to sell the idea of congruence. I want you to truly understand congruency. These 4 quarters of the circle look congruent. Therefore, these segments, I bet you wouldn't argue with me, look congruent as well. In fact, they are, right? So if they're congruent, then I bet you these triangles in here are all congruent. So if all these triangles are congruent, I bet you all these angles right here, this angle, and this angle, this angle, and this angle, I bet they're all congruent. And if you add up all these angle measures, I'm going to grab my pen tool to show you this. If I were to take this angle, say right here, add it to this angle right here, this angle here, and this angle here, all the way back to the beginning, how far did we go around in degrees? I think we went around 360, right? Yeah, full revolution. 360 degrees. And if there's 4 equal parts, then wouldn't we just divide this by 4 to figure out what each angle measure is, which is 90? Right? This is logic. This is how we're going to talk about mathematics, understand relationships, be able to argue for yourself here. Okay, now, we could also, well, I'm going to leave it at that, to be honest with you. We could argue that these are 90 degrees. If these triangles are all the same, then these angles in here, this angle would be equal to this angle, and it looks like all these angles are the same, right? So we know, or either know, or we're going to remember pretty soon, that in a triangle, all the angles add up to 180 degrees, right? If I add up this angle here, this one right here, this one right here, if we add up those 3 angles, it's 180. Well, we already said that this is 90, so the sum of these two must be 90, and then they both look like they're the same to me, so they might be 45, right? So 45, 45, this is 45 and 45, so 45 plus 45, isn't this angle then 90 degrees, which would make a square? So that's the difference, guys, between construction and between look-alike. What I like about constructions as well, I'm going to hide my pen stroke, which if I want to hide it, notice over here it's pen stroke. Every object has a green circle, which means it's being shown. And if I click on that circle, it'll hide it and make it white, right? Okay, so constructions mean that as I move the free moving points around, everything stays the way that it should. This, because of relationships, the way we constructed this, will always make a square no matter what that circle looks like. It just changes our side length of our square. They're still similar, right? So that is the difference between construction and look-alike. So I want you to make a GeoGebra window or GeoGebra screen that looks like this. Make it your colors and your words if you want to, but I want a constructed square and a look-alike square so that you can show me, you know, the difference. All right, good luck, guys.